You tap ChatGPT and type a question. Seconds later, a detailed answer pops up reading like it came from a real expert. You open your iPhone and ask about the topic. The response feels like magic. It isn't. This is a chain of engineering decisions. Seeing how each piece connects makes the whole system even more impressive. So how does ChatGPT actually run on your phone? The latest models handle mobile computing with serious efficiency. GPT stands for Generative Pre-trained Transformer. That is a mouthful, but every single word reveals exactly how it works. Pre-trained models scan trillions of internet words long before you ever type a prompt. They quietly absorb grammar and hard facts without any direct teaching. The transformer architecture relies on a neural network that instantly spots what matters. It uses attention to weigh every piece of your input before processing. Generative systems create original text instead of picking from a fixed list of answers. They weave together fresh language and actual reasoning on demand. The engine generates each word of your output in a steady predictive stream. It predicts the next token repeatedly until the full response takes shape. The real trick activates when you feed the system enough data and enough computing power. That prediction process suddenly produces something that looks and feels remarkably human. The model doesn't think like you do at all. It simply predicts the next most likely word based on everything that came before. That is not understanding. Picture a supercharged autocomplete engine. You ask a question, and the system kicks into a strict pipeline. Tokenization shreds your prompt into tiny text chunks called tokens. Each piece holds roughly 1 or 2 words. The model has already studied billions of these during training. That sheer volume is what gives it its voice. Embedding turns each token into a precise number pattern. This mathematical fingerprint captures how that word relates to every other token in the system. The model already knows what you need. At every layer, it asks which tokens deserve focus right now. That attention mechanism instantly creates a dynamic map of relevance. Your token sequence runs through dozens of attention layers. The model continuously refines that dynamic map of relevance. Generation kicks in, and the model calculates probability distributions across its vocabulary. It picks the next token. It repeats that cycle until it produces a complete answer. Your iPhone screen hides the heavy lifting. The actual model runs on OpenAI servers, while your phone just fires off your prompt and shows the result. The real intelligence lives inside a massive data center. Your phone is just the window. Type a prompt into ChatGPT on iOS and watch the invisible pipeline kick into gear. You are about to see exactly what happens behind the scenes. The app packages your message plus any chat history and shoots it over HTTPS straight to OpenAI's API. The server runs your input through the model and streams the reply back token by token. Your app catches every fragment and paints it on screen in real time. That is how the magic happens. What actually makes the iPhone feel different from a desktop computer? It all comes down to 3 key upgrades. The app is optimized for mobile input and voice dictation. Tactile haptic feedback paired with a streamlined interface makes every tap feel instant. Native iOS features like Siri integration let you invoke ChatGPT straight from your lock screen. You can trigger it instantly through shortcuts automations. It responds to your voice just like a real conversation. You are turning a complex language model into a true hands-free tool. It works in ways that feel completely natural compared to typing. The mobile app caches conversations locally on your device. You can reference them offline and jump back into threads seamlessly. Apple packed a dedicated piece of silicon called the Neural Engine straight into the iPhone 16 and every model that follows. This custom hardware handles machine learning right on your phone. ChatGPT still does its heavy thinking in the cloud. The Neural Engine handles the rest on your device. Your voice commands get processed locally so your words travel faster and stay completely private. The model hears you clearly without ever uploading your audio to a server. Your keyboard learns your personal quirks as you type. Suggestions evolve instantly to match exactly how you think. Snap a picture and drop it straight into your chat window. The AI instantly reads what you just captured. The model scans that image and figures out what it sees. It reasons through the details in context. Forget the phone's hardware. The real story is the model. It carries the real weight. Today's frontier models crush old standards. They boost reasoning and coding skills. They solve multi-step problems like pros. You noticed ChatGPT on your iPhone getting noticeably sharper. That jump in quality has one cause. The model finally caught up. During training, a model like GPT gorges on a massive general dataset. It drinks in textbooks and Reddit posts. It even swallows documentation. That broad foundation hits a wall. Fine-tuning takes a pre-trained model and trains it further on a narrower, higher quality dataset to lock in expertise. Picture the base model as a college graduate who has read everything. OpenAI uses this technique to boost safety and tune the system to human preferences. They sharpen its output until it handles tasks flawlessly. Think of it as sending that graduate to a specialized boot camp for one exact job. General training simply wasn't sharp enough to cover everything. OpenAI gives developers fine-tuning APIs to train custom model versions on your own data, like customer support logs. Feed it legal documents or internal wikis and watch it absorb your company's exact voice. The result is a model that speaks your organization's language. It breaks your question into sub-questions and hunts down the facts. It evaluates every source and refines its understanding before producing a final answer. Deep research or deep reasoning flips the script on speed. The model deliberately takes its time to think through every angle. First comes decomposition, where the model splits a complex question into manageable parts. You get clear step-by-step breakdowns instead of a wall of text. Search kicks things off by pulling data through web search code execution and file reading. It gathers everything needed. Synthesis steps in to cross-check every new clue against existing knowledge. It untangles contradictions and builds a structured answer. Verification checks the work before it ever leaves the system. It hunts down every gap and weak link before delivering the final result. That deliberate process is exactly why deep research answers feel so thorough. You get the full picture. The model is literally working harder by burning more tokens and running extra steps. It slows down to double-check accuracy. Think of the gap between a quick trivia answer and a full research paper. That exact scale separates casual chat from deep analysis. Your iPhone grabs those words and shoots them to a giant language model hiding in a data center. The system streams the answer right back to your screen. It runs on token prediction guided by attention mechanisms trained on trillions of words. The engine figures out what comes next by spotting patterns across that massive dataset. New model updates have sharpened every response. Meanwhile, the iPhone's custom chips keep the whole experience buttery smooth. This neural network relies on attention to dynamically weigh your input. It instantly isolates the most relevant pieces before generating your response. The T in GPT stands for transformer. It powers the whole system by predicting each word of the output in sequence. ChatGPT never runs on your iPhone. It routes every single question straight to OpenAI servers. Your iPhone is just a window. It sends your prompt and displays the result while heavy computation happens in massive data centers. What actually separates base training from fine-tuning? The answer lies in how broadly versus narrowly the model learns. Fine-tuning takes that base model and trains it further on a narrow, specialized dataset. This sharp focus dramatically improves performance in a specific area. Base training feeds the model general knowledge from a sprawling dataset of books and websites. That's the full picture. If this made it click, tap subscribe. There's a new AI explainer here every day, and tap the video on screen to keep going. See you in the next one.